So working with special right triangles, 30, 60, 90. We're working on the second question. We're going to explore how Pythagorean theorem would solve this. Since we have two sides of a right triangle, we can use the Pythagorean theorem. And the Pythagorean theorem, we use hypotenuse squared equals leg squared plus leg squared. Our hypotenuse is always found on the opposite side of the 90-degree angle. So that's our 10. One of our legs is 5. The other leg we don't know. You can call it X. You can call it B. It wouldn't matter what letter you want to call that. We'll call it B in this case. So then we do our math. 10 times 10 is 100. 5 times 5 is 25. Be careful not to call that 10. All right, it's not 5 times 2. It's 5 times 5. So we subtract the 25. That gives us 75. And we're looking at b squared equals 75. Now, for us to figure out what just b is, because we have b squared, we have to take the square root of both sides. To take the square root of both sides, we want to do our factors of 25. What times what makes 25? Anybody have a suggestion what two numbers we might want to use? If you had 75 cents, what groups would we use? 15 and 5? Okay, 15 and 5 works. All right. The trouble with 15 and 5 is that we don't know the square root of either 15 and we don't know the square root of 5. But that's okay. We can keep breaking these down even further. We can break that down into 3 times 5. We still have our other 5. So that still makes 75. Do you have a pair of the same numbers? Yes, so I like to physically circle those same numbers. And what do we do if we circle that pair of the same numbers? You pull that onto the outside. So now we have 5 root 3. That's like taking the square root of 25, right? 5 times 5 is 25. The square root of 25 is 5. So that's why we write a 5 outside of the square root. So that is our value of the missing side. 5 root 3. And if you're starting to see a pattern here, it is not a coincidence. That's the pattern of 30, 60, 90. Let's go ahead and try another one. Again, we have 5 root 3. Nice work. So we're going to go on and look at this 90 and 60. We know the missing angle would have to be 30. So yes, this is a 30, 60, 90 triangle. There is a way for us to predict what our answer is. But if we haven't come up with a pattern yet, Pythagorean theorem in this case will work just fine, because we have two sides of the information. We have two sides of the triangle. The hypotenuse is always across from the right angle. So that's our 12. Our short leg is 6. So we square that. And our long leg, the missing side, we don't know. So we're going to use some letter. I like to use B. You're welcome to use X or any letter you like. So this becomes 144 because 12 times 12 is 144. 36 because that's 6 times 6. And B squared. We subtract that 36 to the other side. Good work. All right, this one might be a little trickier for us to recognize what it might be. Okay, what do you think?
I think that's a breakdown. In case that you want the shortcut, you can break 1 and 8 down by 9 and 12.
9 and 12?
Yeah.
9 and 12. That's a good one to use. So we took the square root of both sides to get rid of the b squared. And as we did that, we broke down the 108. You might need to break it down by 2s if you didn't know. There's lots of different factors that will go into 108. You can play with your calculator a little bit to identify what factors might go into 108. So one advantage about working with a number like 9 is a perfect square. 9, we know the square root. So we can pull that 3 right out. The square root of 9 is 3. Now we have 12. Well, can 12 be broken down? 4 and 3, 6 and 2, either one of those would work. The advantage of 4 and 3 is that we know the square root of 4. So we're going to take the square root of the 4. And when we do that, we're going to bring it to the outside with the number that's already on the outside. Now listen to this carefully. When you bring it to the outside with a number that is already on the outside, we're going to multiply. So that becomes 6 root 3. So because we were able to take the square root twice, 9 was not the biggest perfect square we could use, but that's fine. 36 times 8 would have been a great one to use, but it's probably not the one we all first think about when we think of 108. Okay, I think a 2, I think a 9. Those are great ways to do it. That is so okay. So we got our 6 root 3 as our missing side. So let's take a little review at what we're looking at. The sides of this 30, 60, 90 triangle are 6 for the short leg, 12 for the hypotenuse, and 6 root 3 for the long leg. Okay, let's take a look at the first one we did. The hypotenuse was 4. The short leg was 2. The long leg was 2 root 3. Let's look at the second one we did. We have 10. Then we had 5 for the short leg. See a pattern there? And then we had 5 root 3 for the long leg. So if you start to notice a pattern, let's come on over and see if that pattern is going to exist one last time. So if we have 90 and 30, 60 is the missing angle. So yes, this is a 30, 60, 90 triangle. This pattern only works on 30, 60, 90 triangles. So identifying where a hypotenuse is, we'll do a hypotenuse squared equals leg squared plus leg squared. So we got 6 squared, 3 squared, and our missing side. We can call that any letter we want. I like to call that letter B. So we get 36, we got 9, and B squared. So as we have in the past, we subtract the 9 to the other side to get 25. No, we don't. What do we get? 27. I went to the wrong side of 26. Okay. So what are we going to do here? Take the square root of both sides. And when we do that, we might use numbers like 9 times 3 is 27. That would be the most popular. The only other factor besides 1 and 27. What's nice about 9 and 3 is that we know the square root of 9. So we've got 3 root 3. Well, when we take the square root of both sides, I'm sorry, you no longer have that square on that B. So our missing side is 3 root 3. So have you seen a pattern? Okay, and this happens with all 30, 60, 90 triangles. That's the trick. You got to be sure to apply this only to a 30, 60, 90 triangle. What do we notice about the hypotenuse and the side across the 30-degree angle? The short leg.
I noticed that it's going to be part of the rule, or theorem, I should say.
Okay, the hypotenuse and the side across the 30 degrees. What's the pattern we always see?
We see that the short length, hypotenuse is twice as long as the short.
That is a great way to phrase it.
That is part of the theorem.
Yep.
From later.
The short leg is half the hypotenuse, or the hypotenuse is twice the short leg. The short leg will always be across from the 30-degree angle. That's always the shorter leg. What do you notice about the side? Let's see. What do we notice about the side? I see, they have the word side in here twice. What do you notice about the shortest side length and the side across from the 60? Somebody else want to share what they notice about that? The shortest side and the side across from the 60. The shortest and the side across from the 60. The shortest and the side across from the 60. The shortest and the side across from the 60. The shortest and the side across from the 60.
Well, I can notice that the starting number in front of the roof is the same.
There it is. The long leg is always root 3 times the short leg. The long leg across from the 60 is always root 3 times the short leg. Now, if you remember, when we did 45, 45, 90, we had root 2. This triangle rules has root 3. So now you've got to keep that rule straight in your head when you're doing some of the problems. So let's jump across. We'll talk about the actual rule here. In a 30, 60, 90 triangle, the hypotenuse is twice as long as the short leg. And the long leg is root 3 times as long as a short leg. So everything is related off of the short leg. If you have the short leg, you can calculate the other two really quick. If you don't have the short leg, you can do some dividing to figure it out. So the hypotenuse is going to be 2 times the short leg. And the longer leg is going to be root 3 times the short leg. Those are the two formulas I would suggest for you to know. I wouldn't worry about these other two. We'll fill them in if you want.
2 and 3.
But I think it will help if you just use these two, plug in your information, and we can always solve for what we need. Here, the short leg would be equal to the hypotenuse divided by the 2. And here, the short leg would be the long leg divided by root 3. I wouldn't worry about memorizing that part. It's this first set of rules that is all you need to know. Let's take a look. Now, this first is implied. You need to be sure it's a 30, 60, 90. Okay, it does not work if it's not 30, 60, 90. So assuming this is 30, 60, 90. All right. Assuming this is 30, 60, 90, that would be the 60 because it's across from the longer leg. And this is 30, it's across from the shorter leg. We're, of course, starting out with the hardest one. This is the hypotenuse. I guess it's not the hardest one. How are we going to find? Okay, we have the hypotenuse formula that equals the short leg times 2. That's what the hypotenuse is. The hypotenuse is 8. So the short leg times 2 is part of your formula. What are we going to do to figure out this short leg? Divide it by 2. So we find out that the short leg is 4. It's always half the hypotenuse. Makes life pretty easy. Then to figure out the long leg, It is the short leg times root 3. That's the other formula. So the long leg is what we don't know. You can write the word long leg. You're welcome to put the letter B if you want, whatever you like to do. The long leg equals the short leg times root 3. There you are. The long leg is 4 root 3. You just put a root 3 next to the short leg value. Every time. No decimals. Let's look at the next one. What formula should we start with? We've got two formulas. We've got a formula that has a hypotenuse in it. We have a formula that has a long leg in it. Both formulas have short leg. Both formulas have short leg. Okay. Okay. So here, because they have the long leg, that's across from the 60 is your long leg. We're going to use the formula with long leg. The long leg equals the short leg times root 3. So start with your formula. Don't just write in numbers, and definitely no decimals. So the long leg is 5 root 3. The short leg, if you want to put leg there, you can. The short leg times root 3. That is the formula. We talked about why that is the formula. So how are we going to figure out what this short leg is? Nice job. Divide by your root 3. And that crosses them out. So we got 5 equals the short leg. So 5 equals our short leg. And what do we know about the hypotenuse? We agree out there? It's always double. If you think you need to write a formula to that, you're welcome to. If you notice right away that that is 10, you can drop in the 10. You may. Okay. This next one's a little trickier. Okay, this next one's a little trickier. We have a, notice the side that they gave us, the long leg. The long leg equals the short leg times root 3. You start out with the formula. So here, the long leg is 7. That's okay. So what we're going to do is divide by root 3. Just like we did before. We divided by root 3. We were able to cross the root 3s out. But there's nothing to cross out over here. So what did we learn about having a radical on bottom yesterday? It was called rationalize the denominator. And we do that. All right. So that gives us 7 root 3, and the bottom becomes 3, and that's our short leg. Good job, everybody. The last question is just the same thing. Take a look at what they have here. They have a box, and the box is just multiple questions. This is one question, and then this is a different question. Some people think it's one question. They like, I don't know what to do with the box. One question and 2 other questions. There are 3 questions in that box. Okay, good luck. X is 18. Those are the legs, so we got 18 root 2 would be your hypotenuse. Y is the hypotenuse.
Yeah. Yeah, Mr. Weber.
We would divide by root 2. And we can divide, since they're both radicals, we can divide them. So we had two different questions. Our last example, this is a 30, 60, 90 triangle. So we need to use the rules for a 30, 60, 90. This one was 45, 45, 90. So we use the rules for that. The A is your short leg. The hypotenuse is always double the short leg. The long leg is always root 3. That's what we learned in our lesson. Root 3 times the short leg. If you have the hypotenuse, you know that the short leg is always half of it, and the long leg is always 2 root 3. So then we're going to finish up with the more calculation. Long leg equals short leg times root 3. The long leg is the B. The short leg is your A. And we divide by root 3. We have to rationalize the denominator to get rid of that root 3 on bottom. So our final answer is 4 root 3. And when you calculate two radicals, the same type, when you square a radical, you get what's inside. So this is, let's see where we are. We divided, so that's A. 4 root 3 over 3. And to double that, we get 8 root 3 over 3. When you double a fraction, you're only doubling the top of the fraction.